Welcome to the lesson on nickel metal hydride battery, abbreviated as NiMH battery. In this lesson, we will look at the history, chemistry, and construction of the nickel metal hydride battery. Let us look at our lesson objectives. By the end of this lesson, you will be able to describe the chemical composition and operation of a nickel metal hydride battery. Next, you will be able to compare the construction formats of NiMH batteries. Then, you will be able to identify the historical milestones and key contributors in the development of NiMH batteries. Later, you will be able to evaluate the advantages and limitations of NiMH batteries in terms of performance, environmental impact, and safety concerns. Finally, you will be able to explain the relevance of NiMH technology when working on older or prototype BEVs. A nickel metal hydride battery is a rechargeable battery that uses nickel oxyhydroxide and a hydrogen-absorbing alloy for its electrodes. Older BEVs or prototype models from the past decades might have used nickel metal hydride batteries before the shift to lithium-ion became dominant. Technicians may encounter these older vehicles during servicing and need a basic understanding of nickel metal hydride battery functionality. Nickel metal hydride batteries represent an earlier rechargeable battery technology that shares some fundamental principles with lithium-ion batteries used in BEVs. Knowing how nickel metal hydride batteries work can provide a foundation for understanding the more complex lithium-ion technology. Let us now look at the history of nickel metal hydride batteries. Following the initial invention in 1967, the Battelle Geneva Research Center began pioneering work on nickel metal hydride batteries, focusing on specific electrode materials. From 1967 to 1980s, the German automotive giants Daimler-Benz and Volkswagen AG sponsored this development for nearly 2 decades within Deutsche Automobilgesellschaft. The research yielded nickel metal hydride batteries with impressive characteristics, including high energy density, power density, and a decent lifespan for deep discharge cycles. Despite earlier groundwork, Stanford Ovchinsky, founder of Avonix, secured the official nickel metal hydride battery patent in 1986. Let's look at the chemistry of nickel metal hydride. It consists of a positive electrode, cathode, made from nickel oxyhydroxide, NiOOH, like nickel-cadmium, NiCd batteries. It also consists of a negative electrode, anode. A unique feature of nickel metal hydride batteries is that they are hydrogen storage alloys. This alloy typically combines metals like aluminum, Al, manganese, Mn, and rare earth elements such as lanthanum, La, cerium, Ce, neodymium, Nd, and praseodymium, Pr. Cobalt, Co, might also be included in some variations. During discharge in a nickel metal hydride battery, hydrogen ions, protons, move from the negative electrode to the positive electrode, with the electrolyte acting as a pathway for ion flow. During this charging in a nickel metal hydride battery, the process reverses, with hydrogen ions, protons, traveling from the positive electrode back to the negative electrode, again using the electrolyte as a channel for ion movement. Now, let's look at the construction of nickel metal hydride batteries. There are 2 main types of nickel metal hydride battery designs. They are cylindrical and prismatic. Just like some lithium-ion batteries, nickel metal hydride batteries come in cylindrical, D-cell, or prismatic, rectangular designs with active materials arranged in spirals or flat plates inside a metal case. A cell is a single unit containing a pair of positive and negative electrodes separated by an electrolyte solution that creates a direct current. A battery is a collection of multiple cells wired together, typically in series to achieve a higher voltage output. A 9-volt battery is a common example of a series connection, consisting of 6 individual 1.5-volt cells stacked together. For example, a vehicle battery with a total number of 120 cells. The total voltage per cell is 1.2 volts. Since the cells are connected in series, the voltages add up. A series connection of 120 nickel metal hydride battery cells, each with 1.2 volts, will result in a total battery voltage of 144 volts. Let us now look at the various advantages of nickel metal hydride batteries. They are environmentally friendly and recyclable, making them a sustainable energy storage option. They exhibit high specific energy, allowing for efficient power delivery in various applications. With excellent cycle life, nickel metal hydride batteries offer long-lasting performance over numerous charge-discharge cycles. The design of nickel metal hydride batteries emphasizes safety and durability, ensuring reliable operation in diverse conditions. Now, let us look at some of the limitations of nickel metal hydride batteries. They pose a safety concern due to their corrosive electrolyte with a pH of 13.5, necessitating the use of proper personal protective equipment during handling. They also suffer from a high rate of self-discharge, especially when exposed to elevated temperatures, which can lead to decreased efficiency and performance over time. Let us look at our lesson summary on nickel metal hydride batteries. These are earlier generation rechargeable batteries using nickel oxyhydroxide as the cathode and hydrogen-absorbing metal alloys as the anode. They were widely researched from the 1960s through the 1980s, with contributions from companies like Daimler-Benz and Volkswagen, and officially patented by Stanford Ovchinsky in 1986. Nickel metal hydride batteries function through the movement of hydrogen ions between electrodes, with electrolyte facilitating the ion exchange during charge and discharge cycles. They come in cylindrical or prismatic formats, and when connected in series, for example, 120 cells times 1.2 volts, can achieve high voltages such as 144 volts in automotive use. While nickel metal hydride batteries offer high energy density, safety, and recyclability, they also have drawbacks like corrosive electrolyte and high self-discharge rates under heat.